Hello, everybody, and welcome to Class 2 for R for laboratory work. Today we're going to be looking at R data structures. So, just give me a moment. Oh, so first things first is that there is a lot of material about how to run R. We talked about this a bit last class, but I would recommend going to this site right here. W School. It's a pretty good place to learn the basics of any programming, really. But specifically, the link I have right there is to the R data structure portion of this site. So, what is data structure? Data structure is multiple values held in one object. So last time we talked about objects, usually we're assigning like A to 23, and so A would equal 23, so 1 to 1. But data structures are more lists of pieces of data, like whole columns or whole rows or whole spreadsheets of data points held in one place. It's like in Excel. The listed data structures are vectors, lists, matrices, arrays, and data frames. And we're going to get into all of those right now. Vectors, the most basic data structure in R, it contains a list of items for the same item, same type. So when it says the same type, it means it has to be either a character string or an integer or a numeric. You cannot mix them. So when you make a vector, it has to be all the same type of value. So let's do fruits. And when you make a vector, to make a vector, you have the letter C, then parentheses, and then you just write whatever you want in the vector in a list form. So the first one, banana, comma, apple, comma, orange. So these three things are inside this vector, and we're going to assign it with the arrow symbol to fruits. So let's do that. You can see that it's been done down here. And now we're just going to run fruits, see what it gives us. And you can see it just gives us the three values in that vector right there. So vectors are very simple. It's just basically a list of things held together inside one object. Lists can hold different types of data in their structure. You can combine numbers, strings, vectors, and even other lists. Lists of strings, you can like essentially make a list of strings. So let's look at this. So list is very much like a vector, but it can hold various types of data. And you can see here, it has apples, which is a character string, bananas, which is a character string, and then 50 and 100, which are both numerics. So if you try to do that with this, it should give you a warning like, it still does it. But like you can see here, it actually turns the 100. When you have it in the vector, actually turns the 100 into a character string that like fix itself. So I can't really do it. So let's just make a list, which is list, parentheses, apple, banana, 50, 100 as an example. And you can see here, we just assign this list to this list. And then we're going to print that list out. And you can see apple, banana, 50, 100. And you can see it's displaying it differently from the vector. Vector just kind of just shows it in a column form and a row form, where this is showing them one at a time individually in the console. Matrices are 2D data structures where all elements are the same type. It is like a table with rows and columns. So think of like an Excel spreadsheet. All right. Use R n rows and n columns to control the size of the matrix. So like what the dimensions are, how many rows and how many columns you want. So let's create a matrix. So we're going to assign to this, but let's first get into the actual matrix itself. So use the term matrix, parentheses, on the outside, and then you have a vector, C, a vector right here. So C, parentheses, parentheses, and then we have 1, 2, 3, 4, 5, 6. You can see they're all the same type of data structure. All right, so matrix this, then a vector that you want to work with, and then you essentially assign like how many rows and how many columns you want this data to be. And let's just assign it to this matrix, and it's printed out. So we can look at it, and you can see here it has all the numbers, it has 1, 2, 3, 4, 5, 6, and it goes down. It goes 1, 2, 3, 4, 5, 6, and we asked to have 3 rows, it has 3 rows, and we asked for it to have 2 columns, it has 2 columns. And once again, you can see it goes down. It does not go left or right. It starts at the first cell and then goes down, 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 essentially splitting this data in half. But you can assign the number of rows and columns differently to have different effects. Like, for example, let's actually switch these numbers. And suddenly, now that I had told it to have 2 rows and 3 columns, it is now putting it like that. Just make sure that when you're assigning how many columns and how many rows there are, there's actually enough space for the values you're putting in. Arrays. Like a matrix, but can have more than 2 dimensions, it stores elements of the same type in multiple dimensions. Arrays are useful for working with 3D or highly dimensional data. An array with 1 dimension with values range from 1 to 24, which is the example we're going to show. So this array, first off, we're doing this array, and we're going to assign this vector list. And so when you have, so C, and then 1, and then this symbol means 2, 24. So it's going to make a vector that is the numbers between 1 and 24. As you can see here, let's print it out for you. And then we're going to define, it clears out so it's more clear. Then we're going to use the array function here, array, and then parentheses, the data you want to like split into multiple dimensions, comma, and then dim, which is dimensions, equals C, and then these are the dimensions you want to break it into. So essentially think of the same thing as like column, like row number is the first number, column number is the second number, and then third number is like a third dimension, so like the Z axis. And I'll show you how this visualizes it for you. So there, and I just assign this, run it, and you can see it printed out a piece of data that is 4 rows down, like this 4 right here, 3 columns across, like this 3 right here, and has basically split it into two spreadsheets. So this 2 right here, 1, 2, and that's how it works. All right, now let's go into data frames, which is the thing that you'll be mostly working with. Is like data frames are like a table and a spreadsheet. They can hold different types of data across multiple columns and creates a data. And this is how we create a data frame. So basically a data frame is like an Excel spreadsheet. It's just a spreadsheet. That's what it is in R. And the way that you make a data frame is that you use the function data.frame, parentheses, and then you assign variables value. So training is going to be assigned C, strength, stamina, other. Pulse is going to be assigned 100 on 150, 120. And duration is going to be 60, 30, 45. And it's going to just be assigned to the variable name data frame. All right. Print out the data frame, and you can see here, down here, that training has strength, stamina, and other in it. And training, essentially the thing you're assigning to in the data frame, becomes the column name. And that happens for everything else. Pulse becomes this. A duration becomes this. So data frames, this is how you make it in R. But when you're working with lab data, you're usually not doing this. You're actually running, Excel or CSV files or other types of files into a data frame conversion model, which we're actually going to cover right now. Take a drink of water really quick. All right. So now let's talk about working with CSV files, which is the general way to actually make data frames. So let's start with importing a .csv file. Is straightforward and hard. Spell that right. You first need to set the working directory. So you're just identifying where the files are that you want to import are at. And the way that you do that is that you use the function set working directory, WD, which is right here, and parentheses, and then let me just, an example, and then you just take the path for the file destination. So this is where all the CSV files we're going to be working with here. Into this. And then you copy that and you put it into here. Only hiccup is that these slants, they need to be the other way. You can see here that the slants are going left, but here they have to go right. So you have to replace all those. So after we set the working directory, which we'll do right now. All right. We're going to double check that the set working directory actually worked. And we're going to do this by getting the get working directory, and it just tells you what working directory is actually being used. And you can see get working directory just tells you, okay, this R program is trying to get data from this destination, this file destination. All right, now that we have all that, now we're going to read this file, class 1, example 1. So I've made CSV files for us to work with, well, as examples. And this is the first one that we're going to look at. So you go to use the function read.csv, parentheses, and then the file name that you want to import from the file destination you already assigned, and then which also includes the file type in the file name. And I'm going to assign the data frame df. So do that, and then let's look at it. And see, and it just has everything that the Excel equivalent has is now in the R program. And if you want to double check what the class of the data frame is, it's data frame. The class function, which is a way to see what a class is. I think I covered that in the last class, but as a way. And but you can tell when I ran the data frame in the console, it gave you just gives a bunch of data. This gives out a bunch of data and doesn't even show all of it. It actually reaches a match at 250. And you can see here that it's there's too much data here. We've omitted this amount of data because it'd be too much to show on the console. So if you just don't want to see the first 250 rows of the data frame, what you do is that you use the function head, parentheses, and then inside you put the actual data, you put data frame that you made. And you can see here, it just prints out the first 6 rows of the data frame. This is very useful to make sure that 1, the names of the columns are correct, and 2, if you made a new column, like while working with the data, that the new column is actually there. So it's just a really good way to see like the very top of the data frame really is just for looking at the headers and making sure all the data looks all right without having to look at everything, or at least the first 250 variables. And then if you want to get the first column of the data frame, for example, you either can use an index. So R uses the index of 1 onward, not like Python, which uses 0 onward. So R uses index 1 forward. And you can see here, we're going to put 1 here. And the first column is ID. As you can see right here, it's not highlighting well, but it's right here. So we're going to print that. Ooh. And you can see it's just giving us the column 1 of ID. Or you actually can use the column name to call it out. So if you don't know the number of the column you want, but you know the name, you can just call it out here. And it just does the exact same thing. Just gotta scroll up the bunch to see it there. Does the exact same thing. So you can call it columns by either their number, where they are in the data frame, or by their names. So, and then I'm just gonna show this once again. You know, I want to get a third column, just put in 3, and then I'm just gonna make this easier on myself to clear it, and zoom all away. Now we got the third column again, or you can just do the name. And you see, the same thing happens. So when if you want to get multiple columns, you can use a slice. And a slice is essentially a like range of like what piece of data you want. And for example, here we want to get the first to the third column of the data frame. So we put 1 in the symbol and then 3. And then we run that. And it's going to give us the first 3 columns: ID, height in centimeters, and then blood pressure. So that's how you can get a slice. You don't have to like do that. You can like change it to 2 to 4. You don't have to always start with 1. And you can see here, it starts with height and then goes to BMI. So we got different like range of the columns. So now if you want to get rows, you put in data frame, brackets, and then whatever row you want to look at. So we want to look at the first row, print that out. It gives us the full first row, 1, like the ID, the height, the blood pressure, and the BMI. And then, for example, or if we want to just get the third row, we do that again, and it gives the third row. If you want to get a range of rows, just like the range of columns, it's the first row you want this symbol, and then the last column you want on that. And you can see we get, let's do this. You can see we get the first, the second, and the third column, and you can just really, once again, you don't have to start with 1, of course. You can start like here, I started with 30. We're getting row 30, and then we go to 60, or 60. All right. So that's a basic way to look at data. Look at a data frame while you're working with it. So now let's talk about how to add a column to a data frame. First off, you're going to need like data to put in the data frame. And the way we're going to do that is actually some math. So the way that you do it is that you have data frame that you already have set up, and then brackets, and then the name of the new column you want to create. And then you assign a value to that new column. And that the way that we're going to do that today is actually I'm going to take the data for each row for height and divide it by the BMI. All right, so let's look at this. You can see this is the data before I add a column. It's ID, height, blood pressure, BMI. But now let's run this, and then let's run it again, and you can see now height / BMI has been added as its own column. And you can add like raw data into there. It's just you just need to make sure that equals the amount of rows you actually need when you add the raw data. So this is basically in Excel you would make an equation that divides this by this and does all the way down. This is the same thing just within R. So think of it like that. So you can see here. Let me bring up my calculator. You see here the first column is 154 divided by, so the height is 154, and then divide that by 20, and then we get this number, 7.7. So it just does that for every single column. So like the next column would be 192, 192 divided by 19. Divided by 19. And that creates this very long number, 10.1 essentially. And you can see here, it's right here. So it's just like an Excel. Okay. So let's move on. Now we're going to create a new data frame in not a new data frame. We're going to create a new column in the data frame that digitizes the blood pressure reading. Because right now you can see that the blood pressure reading is rated as low, medium, or high, and that is a categorical value, and it's somewhat hard to work with. And so a lot of data processing requires that like categorical words, like high, medium, low, big, small, large, things like that, things that are like somewhat quantitative or so qualitative you can assign them to numbers. So the way that we're going to do that, clear all this before we start this, is first we're going to create a new column, and it's going to be data frame. The name of the new column is blood pressure digits, the digitized version of the blood pressure. And then data frame, and then we're actually going to assign it to blood pressure. So we're going to copy blood pressure over this one, and then I'll explain more why we're doing that in a second. So let's do that. All right, you can see now there is a copy of blood pressure digits that have all the same values. All right. And the reason why we did that is because we're actually going to go through this new column. We're actually going to change these individual values into their number of representatives. So first off, we're going to replace low, like the word low, with the number 0 in the blood pressure digit column. So the way we do that is that we're going to take data frame, brackets, blood pressure digits. Sorry, we got a little lost there for a second. We're still the same thing. You can take data frames, blood pressure digits, and then we're going to assign it new values. But when we're assigning it basically a new value, we're going to replace all the low with 0. So we're using the function replace. And for replace, you need the data you're working with, which is going to be data. We're going to be taking the data frame blood pressure digits column, and then the work data you're working with, and then the data that it's going to be looking at, and then equal sign low, it turned to 0. So basically what this is saying is the replace function is they're taking this piece of data and it's going to go through each row of it right here. And if this row equals low, it's going to turn that low into a 0. And let's look at this really quick. So I just did it. And now you can see that these lows are now zeros. All right. And now we're going to do the same thing for medium and high. We're going to change medium to 1 and high to 2. So let's do that really quick. And data frame. And now you can see that all the blood pressure digits column are all now numbers. And the reason why I copy the blood pressure onto a new column and then change it is because it's just simpler and also leads to less chance of data loss. It's just a simpler way. It's like a very simple and somewhat brute way of doing it, but it does the job. All right. And then after all this, after all these changes we've made, actually, let me double check something. Class 2. Make sure they're not here. Good, good, good. Right here, we're actually going to take these modifications that we have done to the data, and we're actually going to export them out. So the way you do that, you use the function write.csv, and then you put the data you want to export, and then as a CSV, and then you have the name of the new file. So let's look at this. We'll run that really quick. It's ran. You can see here, once I refresh this, there's going to be a new piece of data. See right there. So this is original data. Just make that like that. And let's look at its offspring. And you can see here that the new, let's make this a little bigger, the new columns are now added to the original data when you export it. And I suggest when you do this, you actually like do what I did here and just have like modified or version or something to the data so you don't overwrite the original piece of data because you don't want to lose data ever. You gotta hoard that stuff. And you don't want to accidentally erase it and then realize you've done something wrong, but then lost the original piece of data. So always name it something different. Let's close these two. So, with all this done, it's basically working with data frames is basically working with Excel, and it's like, oh, why would I want to do this when I can just do an Excel easier? I mean, that's a good point. So the real strength here is actually somewhat automating work by running multiple CSV files through the same process at once. So, for example, we're going to set the working directory to multi.csv. So I have a folder here, multiple CSV files in it. All right. And so we're getting this working directory so it knows it has to pull files from here. This is very important for this part because you don't want it, because this program is basically takes all the CSV files from one folder and then works with it, and so you don't want it looking around like taking all your CSV files from your whole computer and trying to run it. That just will cause issues. So you need to make sure it knows where it should be looking, and then we're going to get a file list, and we're going to do this by using the function list.files patterns.csv. So it's the list.files is a function which essentially looks for certain files in a area, and you tell it what type of file you want to get by giving it the handle for the data type. All right, so let's do that. Set the directory, the files, and then let's actually look at the files. And you can see here it's class 2 example 2a, and then 3A, and then 4A, and you can see they're here too. So it's found all the files in the folder I wanted to. Now we're going to start to make a for loop, and so it is going to take for each file in the file list that we just made. So it's going to go through all these one at a time through this program. And first, it's going to read that file into a data frame. Then it's going to do some math to it, same type of math we did before. We're just going to change. It's going to do the height to BMI equation and make a new column for that. And then make a blood pressure and then digitize it. So the same thing that happened last time that we just did up above, we're going to do this list of files, and then we're going to assign file name, paste, substring, file, 1 character file, mod, this. So this is a very elaborate way. I'm going to get into it more. So basically it's you are taking a substring of the file names, the one of these file names. You're shaving off the last 4 numbers off of it. So we're taking the first symbols off of it. So we're shaving off CSV dot, and then we're adding to it with the paste function the mod.csv. And we're doing that to basically just create a new file name. So it can, so when it exports the file again, it doesn't overlook the old file. So this is this is a somewhat not tedious, but this is a long line of code just to make a new file name. So when we export it right here, it doesn't. We're not using the same file name as the source material, so it doesn't overwrite it. All right, so let's run this really quick. And let's go look at the file. And you can see now there's modified versions of all these files. So let's look at A, what's 2A and 2B. And you can see in here now it is they're both like this original file has been modified in this one and been giving a different name of _ mod. All right. So that is the way to look at to basically do bulk adjustments to multiple CSV files at once. All right, now let's talk about reading text files really quick. So first you need to set the working directory. This right here. Set working directory, which is going to be the class again. And then text file, you're going to use the read dlim.text file, this function, and it just reads text files from the folder. So and it's going to read this text file. All right, and then let's print it out, and it's actually like genetic data. All right, so that's how you read text files. Pretty a little tangent I want to do before moving on. So now that we've done that, we're actually going to be getting to merging data frames by row. So you do that with rbind, and there's a great little the article right here that explains it very well. Just want to link it. This would be supplemental to my lesson. So first off, we're going to create 2 data frames. All right, create these 2 data frames, and then what we're going to do after we create these 2 data frames, as you can see here, is we're going to rbind them. Binding the 2 data frames by rows titles have to match. So basically, you see here that in this data frame we have, I'll just look at it in a second. So we're going to use rbind, the function rbind, and put the 2 data frames inside. So from that, here's the first piece of data. This is the first data frame. You can see its columns are A, B, C. Run this. You see again, this is the second data frame, and even though the different numbers, they have still the same column names. And this is key. The columns have to have the same names when you're combining them with rbind. And now let's look at the combined version, which is we assigned a df underscore new. And you can see here it has the data from both of the rows. All right. Now we're going to look at cbind, which is binding data by column, not by row. First off, we're going to set the directory like we always do. And then we're going to read 2 CSV files. And here we're going to look at example 1 and example 2. We're going to read these 2 CSV files I have in my folder. And we're going to, well, I talked about cbind. I might have messed that up. Anyway, this is how you do rbind with CSV files. That should not be CSVR. So it's basically the same thing. Let's look at the head of the first piece of data, the CSV file we got. Let's look at the second one, and then we can look at the combined. And it's hard to tell because it's a lot of data, but they have been combined. So that's how you can combine like 2 pieces of CSV files together in R with rbind. Moving on. So there are ways to bind 2 data frames together, even if you don't have all the same columns. This site has a very good explanation of how to do that. I'm going to still run with you through here. The first part is actually getting a library called Dipler to do this. So we're going to get that, get Dipler. And it's going to tell us some issues, but it's going to be fine. Then we're going to create just 2 random data frames that have different columns. So you can see here data frame 1. Data frame 1 has the column A and the column B assigned. And then data frame 2, it also has A and it has B, but it has this third one, C, that the data frame 1 doesn't have. And usually, and when you're using rbind, it wouldn't allow that wouldn't be allow these 2 to be combined, but with Dipler, it does. So let's make these 2 data frames, and then with solution Dipler, use the function Diplers, bind rows, and then you put the 2 data frames you want to bind in there, and we're going to assign it to data frames new. Let's print that out, and you can see it has the data from data frame 1 and data frame 2, and where it's actually missing, like the column data, like you can see here, data frame 1 it doesn't have C, so for the piece of row data it's missing, it just puts NA. Not there. But they are combined. It's just that you have like a hole in your data. That's how you combined rows, even if you don't have all the columns. And this is dangerous because you can create data with holes in it. It's usually it's better to use rbind because then it tells you there's something wrong. If you think that the data's got the same columns, use rbind because then it tells you if something's wrong. All right. And now we're going to do the same exact thing, but with CSV file data. So let's hit the working directory as we always do when we're working with files. And then we're going to read data frame 2 and not data frame, example 2 and example 4 as data frame 1 and data frame 2. All right. And then we're going to assign it to new data frame, Dipler, what we did up here. And you can see here, these are the two data frames, the heads of them. You know, this data frame 4 is missing BMI, as you can see right here. But now that we look at the combined data, you can see here there's a big just hole where the data was because 4 doesn't have it, so it's just NA and NA, NA, and NA until it's 2. The data from 2. All right. So now we're going to get into merging data frame by column. And this site has a good written explanation of it, and we will go over it more by example right now. So first off, we're going to create two data frames. First one is A, 1 through 3, and then B, X, Y, Z, and then C, A, B, C, D, true, false. So various types of data. To data frame 1, data frame 2. Let's print those out really quick so you can look at them. So here's data frame 1, here's data frame 2. So now we're going to use the cbind function to bind them. And it works very much like the rbind. It just takes, you just use cbind and then you put the two data frames you want to combine inside them. And then let's go run it really quick and assign it to combine. And now let's print combined. And you can see here that the columns have been just smushed together. So data frame 1's AB and data frame 2 CD have just been put together into one piece of data. And now we're just going to do the same thing, but with CSV files. So as always, we're going to set working directory. And then we're going to import to data frames CSV files. And let's look at them really quick. That's, I don't know why I did not put head on these. Let's put head on them. As we're here, that'll make it way more visually appealing. All right. So let's Control Enter to run this. Here's the head of the first data frame. Run that. The head of the second data frame. And then we're going to use cbind to bind them together. And then we're going to, let's just edit that too. This shouldn't matter. And you can see here, it has smushed the two elements together. And here's an important example is that it does not like match things. It just literally smushes together. So even though this one has ID in it, and this has also the column ID, it just smushes them together. It does not care. So be careful with this. So, because it will not change the names at all. So you can have columns with the same name in your data. So now the cbind only can combine pieces of data that have the same number of rows. So let's now look at a way to do that, to combine them with unequal number of rows. So bind data frame by column with unequal rows. So first of all, we're going to create two data frames right here. The first data frame has going to have 3 rows, and the second data frame is going to have 2 rows. Let's run this, run that, look at them really quick. The first one you can see 1, 2, 3 rows, and then the second one has 1, 2. And then we're going to combine data frames by column, combine by reference by, one by the column, or align the data frame. So, want to use the function merge, which has the two pieces of data you want to merge. And then you're going to basically tell it like which column is the reference column. So for us, it's A. In this example, it's A. So it's going to look at this row A in data frame 1 and this row A in data frame 2 and kind of try to match them together so it can make the data, so it can line up the data where it should be. And then you just assign all the true. So let's run this. And then we're going to look at the combined. And you can see, so this is the original piece of data, two pieces of data, and this is the new one. And it has basically aligned the second data frame to the first one by the column A. So one of the one value from data frame 1 is right next to where it should be, and false is where it should be. And then you can see here it is NA because there's missing data. So let's actually do this again. But instead of having 1 and 3, we're going to have 1 and 2, we're going to have 1 and 3. Run this again. There's a little adjustment I made right here. And we're going to combine them again and print them again. And you can see that it has merged them based on the value they both share within A, column A. So they both have 1 and they both have 3, but data frame 2 does not have the second row, so it's just NA. All right. So we're going to do the same exact thing, but we're just going to work with the CSV files. So we're going to set the working directory of the files we're going to work with again, and we're just going to do the same exact thing we did just before, just now, but with different, with CSV files. And then we're going to do combined, same type of thing, but this time we're using ID as the thing that matches it. And we're going to combine it. And you can see once again, since they have the same name, it's just, this time it actually gives it like, this is height CM X and this is height CM Y. So it does like give them like different row names, but once again, you can like smush together a CSV file data that has the same columns here. All right. Now moving on. And this is the, it seems like I just repeated this again. It is setting the combining two data frames by the column, by the ID. So we're going to set working directory and then make two data frames for these two pieces of data. Let's look at them really quick. You can see that one data frame has IDs, height, and blood pressure, and the other data frame just has IDs and BMI. And let's say that these are just two pieces of data from patients that you have, but you want to combine them by their patient ID. You use the same merge function we just actually used up here. Have the two data frames you want to work with. Assign whatever you want the combination to be directed by. So we're going to do ID because they both have ID, and this is like the identifying information of the patient, for example, and then all true. And then let's look at the combined. Now you can see that now we have a combined piece of data that has all the rows that we want, and it's aligned to the patient IDs. Let's see where we're at. So now we're going to be looking at data cleaning. First off, we're going to, this is a good resource if you want to read up on it. And first off, we're going to make an example piece of data that has NA in it. So this NA is like missing data, doesn't mean anything. When it's actually printed out as a data frame, you can see missing data. And then you can use the function omit rows with NA. So you use the function na.omit and it actually gets rid of rows that have NAs in them. So let's look at it again. You can see here, it's very drastic because most of the rows have NAs in them. It has gotten rid of row 1 and row 3 because they both have NAs in it, and you only left with like the middle one. So if you really have like you want to like cut down on like not full data present in your file, very like effectively, that's is how you do it. Now let's do the same thing, but with CSV files. Once again, set the working directory of the file you want to get. Read that file into a data frame. Read the head. And we'll have to read that. Show the head. So let's show, and it has NAs here and here. And then we're going to omit the NAs from the data frame and assign it back to itself. So it kind of like deletes everything. Delete gets rid of all those NAs in the data. Let's print it again. And you can see ID number 3, which didn't have a full piece of data, is gone. And so is 5. It is also gone. And so is 1. So once the data has been removed due to this various use of NAs. All right. So now you can actually be way more specific. You can be more specific about like what columns you actually want to remove. So like let's say that if one column has NAs, you don't care. But if the other one has a missing data, then it's unviable, so you need to get rid of it. So this is how you do that. So let's do an example. Let's make a example piece of data that has missing data, NAs in it. All right, look at that data. It's just the same data we had before, missing. And then you do omit rows with NA specific column of data frame. So you get the data frame you want to omit NAs from, and then you do exclamation point, and you do the function in brackets, and then you do the function is NA. So basically this function asks, is this column, this is row, this value an NA? This is what this function's asking. And then you're asking it of the this row right here. So data frame 1, row A. So let's actually go backwards. So it's looking at data row. The function is looking at data frame A, row 1 of data frame A, and if it is NA, so it's going to return a boolean, and then its exclamation point reverses it, so then it becomes false, and then if it's false, then it is not added to the whole data frame. All right, and now you can see here. Let's actually run this again. You can see here that the NA from A has been removed, but the row that has NA and B has not been removed. So this is a way that you can like pick very specific columns you want to. And I'm going to explain this again. So you have your the column you want to look at, data frame, $, A, so the column you want to look at, and then basically it's asking, is this NA? And if a column does have NA, it's going to return true, and then this exclamation point actually turns that true into a false. So since it's false, the this bracket system thinks that, oh, it's false, I should not add it to, I should not use it, so it tosses it out. And so only rows values that are not NA are actually kept. All right, let's go into something. I'll remove CSV NAs with certain columns through a CSV file. So we're going to do the same thing again, just with the CSV files we always do, just to show like the actual practical use. So let's hit the working directory, and then read the CSV file, and then the head. Let's look at the data, and you can see there's missing pieces of data in multiple of the columns. But then we're only going to be looking at the blood pressure column when we're removing NAs. So the same method again, and you can see there's still NAs in the heights, but for the blood pressure, they're all gone. So now we're going to talk about how to remove non-NA values. So let's say that there are values in your data that are not NA, but you still want them gone. Let's say that like they certain values are just like they're not functional. Like instead of putting NA, but whoever's collecting data put X or put N/A in your data, and you need to get rid of that. This is the way that you do it. So the best way to do that is actually turning that type of data you don't value want in your data into an NA, and then removing all the NAs. So, for example, we're going to create a data frame that has 3 columns, 3 rows, an A and a B. Let's clear that really quick. Oop. X and X. And then now we're going to do a little programming magic. We're going to do data frame bracket if data frame equals X, turn that value into NA. So we're going to do that. So this is the original piece of data. Run that piece of coding logic. And now all of a sudden, all these X's have been turned into NA. And now it is very simple to remove those originally X values from your data by using the various ones we have just discussed. So we're just going to do NA.omit here function on the data. And you can see now those 2 rows that had NA in them are gone. All right, and now we're going to do the same exact thing, but instead of removing X's, we're just going to remove blanks. So if you have like blanks in your data and you don't want blanks, the way that you do it, for example, we're going to make these data frames, and example data frame, print it out, and you can see there's just blank pieces of data, blank cells in the data, and those are represented by 2 quotation marks with nothing in it. There's just nothing in here. All right. So now, same exact deal. Do this programming logic, which turns all blanks into NA. Print it again. You can see now these blanks have become NA. And then let's just do omit NA. And there you go. Get rid of all those blanks. And then we're just going to do the same exact thing, but with CSV files instead. So as always, at the working directory, get the file. Let's look at the file really quick. You can see it has X's right there. And we're going to turn all those X's into NAs. Whoop, you can see all those X's are not NAs. And then we'll get rid of all those NAs. And there you go. And that's how you do it with actual CSV files. So for this example, we're going to be running this data we did before, the combining and the data cleaning, but we're going to do multiple files. So we already did something like this before. with multiple files, but now we're just going to do it again really quickly and just use these other new functions we just introduced. So like always, we're going to set it to a new working directory, which is this. And then we're going to take files. We're going to get all the files in this folder in that working directory and get the file names like we have done before. And you see here's the new file names. And then we're going to merge all these. So the first thing we need to do, we need to make a baseline file. So first file on to be baseline template. So basically we're taking this first file right here, example 2b, and we're going to be using it to basically paste everything else to it. So it's the beginning of, it's the foundation which we'll add everything else to. So we're going to assign file 1 to df total as a CSV file. So we're going to read this file, the first file, and here to be our baseline. Let's look at the head of it. Here's the data. Now we're to run a loop, all files, all loops second onwards, since 1 is already assigned, since we're using the first file as like the foundation to paste everything else onto. So we're like before, we use 4 files in, but instead of just running all the files, we're actually doing 2 onward, so 2, and then this symbol, whoop, that's not good. And then this symbol, and then the length of the file is actually available. So this length function gives us the length of the number of files in there. So it's actually going to be 3. So it does the whole thing. And then it's going just to read the file, and then it's going to is data frame 1, and then it's going to take the data frame the total file and rbind it. So bind it by rows to the first data to the file that we just called, and then actually assign it to like the collection of all of them. So data frame total. So let's do this, and let's look at it. And you can see here it's hard to tell, but yeah, all the data has been combined. All these pieces of data have been combined. And then we're going to turn all the X's and all the blanks into NA in this big piece of data. And then we're going to get rid of all the rows with NA inside the big piece of data. So you can see here, all these NAs are now gone. There we go. And then you can just export it like you usually do. Let's write CSV file. Should add this down here. So add as, and then what are these files called? So, and then we're going to make a CSV file of all this right here, and you can see right here it's been combined. All these data has been combined and then cleaned of NAs in the rows. All right. I know it's been a long one. It's probably going to be the longest one we're actually going to work on during these sessions, because it's actually the most useful is actually manipulating data. But that is everything. Thank you for watching, and there's actually homework this week. That's actually homework. The homework is, let me bring it up really quick, load class 2 homework CSV onto your instance of R, and then subtract year of death by year of birth to create the age of death column. Then multiply the age of death by the diet score to create a diet times age of death column, and then export the modified data as homework class 1 homework 1, and then email me the results as CSV and R code and X file as a text file. And the way that you save R as a text file, you just go here and, well, you just, you change this. So you can just take your R code and you can actually change the name here, the txt, and it'll become a text file. I'm not gonna do that now because I'm actually running this. All right. Anyway, that is everything. Thank you for listening, and I'm looking forward to see how you make your first program in R. Thank you. Bye.